Hello and welcome, I'm your Code Monkey, and here is a fun drag racing minigame. You pick a car and opponent and go race, step on the throttle when the light turns green, change gears at the perfect timing, hit the NOS and wipe out the competition. It's a simple minigame that is very much inspired by the many drag racing flash games that I played 20 years ago, simple but very fun. Making this game involved building some interesting things, like for example using animation curves for the gear ratios. I use a nice 3D UI with some gear shift animations, and a bunch of tiny effects to really sell the sense of speed. You can look at these two shots where both cars are moving at the exact same speed, and you can clearly see how one of them sells the sense of speed much better. Adding all of these tiny effects really makes a big difference. I'll mention exactly what they all are in a little bit. There is skill involved in this game, so go ahead and download the free project files to see how fast you can do it. The reason why I made this game is because right now there's an awesome sale happening on the Cinti store. Pretty much all of their packs are currently at half price. Personally, I love their low poly style. I covered lots of potential games you could build with these assets in the previous video. And on top of the regular discounts, they have a flash deal every week with an even deeper discount. This week, the massive discount is on the Street Racer pack, which is exactly what I used to make this minigame. This one has over 1,000 prefabs, lots of cars with tons of customizable parts. You can swap out the wheels, the paint job, add some spoilers and so on. It also includes a bunch of characters with tons of customization options, and a really nice looking environment of some dogs. So check out the entire sale in the Street Racer pack link in the description. Here let's see the game that I made pretty quickly using that pack. I think in total I worked on this minigame for about 10 hours, and the final result looks pretty great thanks to using these awesome assets. You can download the project files for this game link in the description. In there you will find two scenes, one which is functional but only has basic cubes, and a second one which is using all these assets. If you pick up this asset pack, just import it directly onto the project and all of the assets should load correctly. Okay, so here let's inspect the game to see what we can learn from it. First, let's see it in action. So here it starts off with a simple car selector window. I can pick any of these cars, they all got varying different stats. I can also pick the car from my opponent, and I can also set the AI as either easy, normal, or hard. So for example, let's go with these cars and let's race. Here we are, ready to go, so let's start the countdown. And there you go, 3, 2, 1, and after the light, yep, going off. Now I'm changing gears, I'm trying to change as quickly as possible. There you go, changing, I'm also using the NOS, there you go, super fast speed up. And the camera is shaking, the car is going super fast. And yep, there you go, look at that, I won. Alright, awesome. So now let's inspect all of this. Starting over here from the car select window. Now this window is actually pretty interesting. This window itself is a UI element, but as you can see the cars are actually 3D. So how this works is the cars are actually over on the side. So if I go, yep, over here, so on position 02000, over here are both cars with a basic animation just rotating them. And then as you can see, each of them has a camera looking straight at them. And for that camera, the way that it's working is over here on the output. Instead of outputting to the screen, it is outputting to a rendered texture. Now I covered the render texture in detail in another video. They are really useful. So it renders onto this render texture, and then on the canvas itself, over here, there's a simple raw image showing that render texture. The rest of this UI is all pretty basic. I've got a basic button to change the car, which modifies the visual transform and updates the stats. For the stats themselves, they are stored in a simple scriptable object. So here is the definition, pretty basic. So it just says a transform for the visual prefab, the NOS amount max, the car speed max, the acceleration, and the brake speed. Then for the visual, for these bars, I'm just using some filled images. So it's just an image component with over here the image type set to filled, horizontal, and here it has the fill amount. Although remember that in order to use this filled amount image setting, in order to use this, you must have a source image assigned. If there's no sprite here, so if I click on delete, nope, like this, you cannot access that, so it needs to have a sprite assigned. Over here, I'm using the built-in white pixel sprite. If you search for it and you don't see it, make sure on the top right corner you click on the eye icon. That will show all of the built-in sprites. So with this, I can select any of these cars. I can select my car and click on race. Then here we are waiting for the player input before actually starting the countdown. How this is handled is by a very simple state machine. So this is pretty much exactly like I covered in my free course for the game state machine for that one. When the state is waiting to start, then it simply waits for player input and starts the countdown. Then also, just like in the free course, I separated the logic and the visuals. So on this script, there's only the logic for the countdown itself, there are no visuals here. And then I have another UI script, and only this one handles all of the visuals. The images simply change color as the timer counts down. By the way, like I said, this was inspired by the flash games that I played as a kid. So before I actually started working on this game, I went to YouTube to look at some gameplay. Basically, whenever you make a game or prototype, definitely start off by doing a bit of research first, study what other games in the similar genre have done, see what works and what doesn't, and then give it your own unique twist. Now for the car itself, it's using a pretty basic script. This is pretty small, most of the logic is really just on the update, so really just about 100 lines. This is really only a drag racing game, so it doesn't need a complex car controller, it literally just drives forward and changes gears. So over here I've got some simple throttle acceleration input, then I've got some braking, even though it's really only used when the auto brake is enabled, which is after completing the race. There's really no point in braking in the middle. Then some input for changing gears, and then for changing the NOS. Now for the input, as you can see over here, I'm using a whole bunch of funcs, so these are delegates. I'm using this instead of accessing the input directly. I'm going to talk about this a bit more when I talk about the AI, but basically it's the same thing that I used to record the trailer for my upcoming Steam game Dinky Guardians. Go ahead and add it to your wishlist. So here the car controller is pretty simple, just move forward, change gears and use NOS, all of it pretty basic. The more complex part is actually how the gears work, and how I handled that was with some animation curves. This is a really awesome Unity feature that a lot of people don't know about. They can be used for so much more than just animations. I covered lots of use cases in a tutorial video. Here I'm using them for defining the acceleration curves to essentially handle the gear ratios. So I've got all of these curves for each gear, and here you can see the curve. The vertical y-axis, that one is the amount of acceleration, and the x-axis, that is the total car speed. So over here on the first gear, you can see it gets a ton of acceleration at low speeds, but then quickly goes down. If you're trying to use the first gear while the car is near the max speed, then you won't get much acceleration. Then for the second gear, it's pretty similar. It also has a peak, but the peak starts off a bit more in front. Then same thing for all of the other gears, so all of them have a peak slightly a bit more ahead. I basically just googled car acceleration curves. You can find all kinds of graphs on how the actual gears actually work. Basically on any graph there's a certain point where it's actually optimal to change gears to the next one. For example, here on the first gear, it starts going down, let's say around 15 to 20% of max speed. It starts going down here with acceleration under 80%. And then on the second gear, you can see between 15 and 20% of max speed. Over here, the acceleration is over 80%. So technically, around here would be the best spot to change this gear. Now, obviously, let me point out this is definitely not a physically accurate simulation, but for an arcade game, this simple process actually works quite well. Here I am playing, and I'm going to stay just in first gear. So there you go, going up, and now I'm not changing gears, and yep, look at that, the max speed is actually not increasing too much. So it's constantly still going up, but as you can see, the acceleration is super low, whereas if I change gears, and if there you go, now it speeds up quite a bit more. So if I try to change gears a bit way too late, so let's wait for that one to be really at the end, then really at the end, keep waiting, and okay, almost at the end, let's see how long. So 14.4 seconds, okay, now let's try again. So now I'm going to swap gears a bit more around here, which is a bit better. So swap it out, keep going, and let's see how fast it goes. And if there you go, 12.2 seconds. So quite a bit of difference. This is where the skill comes in a game like this. And that is basically how the car works. As you can see, it's all pretty basic. Also, by the way, in order to get a value from the animation curve, really you just get the animation curve reference, and then you just call the evaluate function, pass in the time value, and it gives you the Y value. Then for the UI itself, for this I went with a fun 3D UI. Basically I wanted to only use assets from the Street Racer asset pack, and this pack really only has 3D models and no UI elements. So I needed some kind of speedometer, and I browsed the asset list and I found this boost gauge. Which, by the way, as you can see, this is not exactly the one that I'm using. So this is actually a great practical tip for you when you're using some assets from some asset pack. Remember that you can always take whatever assets are included in that pack and slightly modify them. That's exactly what I did. Personally, I have no 3D modeling skill, so I definitely could not build something like this from scratch. But given something like this, I can definitely modify it to get it looking a bit more exactly like what I want. So I took this original boost gauge, and then I just used ProBuilder, which is Unity's built-in 3D modeling tool. This one is somewhat basic, but it works great for these kinds of minor changes. So as you can see, I added a bunch more dashes, made them a bit thinner. I also elongated the needle a little bit and got exactly what I wanted. Oh, also, if you don't know how to make a 3D UI just like this, as you can see, these are all 3D elements. Just like the other cars, they are also played offset, so these are on 0, 1000, 0, so just to be offset from the actual world all the way down there. So these are regular 3D models. And the way they are shown in the UI is they have a second camera. So here I have another object, so this is another camera. And what you need to do in order to make this a secondary camera is over here on the render type, instead of making a base camera, make it an overlay camera. And then you go back into the main camera itself, And over here, note how this one is a base camera, and then down here you have the stack, so this is the camera stack, and you can here add all of the overlay cameras. So that way you have the main camera, and then on top of it, you get the UI camera. This is a really interesting way of building a UI. It looks great, and also importantly, with this method of using two separate cameras, this second camera will not be affected by all of the speed effects that won't be applied on the first camera that I'm going to show in a little bit. Now the rest of the UI is all pretty basic. So for the needle itself, that one just rotates. So that's just a basic rotation on the y-axis, so all of it pretty basic. The rotation is supposed to be based on the RPM. Also for calculating the RPM, this is not a simulator game, it's more arcadey, so this is definitely not a perfect RPM simulation. Here for the RPM math, I just did something super basic. Basically just went through the animation curve for the acceleration graph. I just went through it and basically inverted it. So this way, when the point of the graph is near the top, that means low RPM, and when it's down here close to the bottom, that means max RPM. Again, not realistic, but it's simple and it works actually quite well. Then the UI also has this basic progress track down here, really just two objects moving alongside a normalized position value, and then the NOS gauge itself. Here it's a super basic object, just got the NOS, inside got the NOS tank, and note how the pivot is on the bottom. I covered how you can modify the pivot in another video. Basically, it's all to do with how you are clever with positioning the child objects relative to the parent. So over here, the child object is offset above, so this way I can modify over here the Y scale and make some super basic NOS capsule container. Then the more fun part of the UI is actually down here, the gear shifter. This one was actually quite fun to make. Look at that, it actually looks pretty interesting. I'm quite happy with this. For the visual, I actually made this myself. It really is just a bunch of cubes in a sphere. So this one down here is a cube, the dashes over here, they're a cube, that one is a cylinder, and that one is a sphere. So all of it's super basic, but it actually looks quite well, I think. And the reason why it looks pretty good is because of the animation. So here, this object has a basic animated component, and inside it, I've got all of the various animations. So starting off on neutral, going from neutral to first, to second, third, and so on. The animations are all pretty basic, really just goes from one place to the other. When seen in action, the gear stick actually looks quite nice thanks to all of those interesting animations. Next, for the car visual. Again, like I talked about time and time again in my free course, I made sure to separate the visuals from the logic. So the car script that I showed a while ago, this one only handles the logic, and then I've got a separate script, this one only handles the visuals. So here it's got a reference to the wheels to rotate them, the brake lights, the exhaust smoke, and so on. This asset pack actually has all of the car parts, all of them separated, so that makes handling the visuals actually super easy. All of these objects are all separated, so I could even modify the hood, I could modify any of these things if I wanted, but the main one is really just down here, the wheels. So I've got the wheel objects, and I can easily just rotate them in any direction. Although for this one, even though this is simple, I actually did have some issues. The first time I tried to rotate, I actually did it on the wrong axis, which was pretty funny. Then I also had tons of issues where the rotation wasn't working. Working with rotation is always super tricky. Usually I prefer using Euler angles because I find them much more intuitive. But it wasn't working at all, the wheels would just randomly stop rotating at some point. So over here for the wheel rotation logic, for this one I was actually forced to use quaternions. By using this method instead of Euler angles, with this it actually fixed the rotation, so the wheels now rotate perfectly. For the brake lights, they are some very basic lights. Then here for the visual logic, just set them as active if the car is braking, so again separating the visual from the logic. So the visual asks the logic script, are you braking or not? If so, then enables the visual. Then this asset pack also includes a whole bunch of particle effects. One of them is this really nice smoke. This one is only triggered when the car actually moves. And this one, as you can see, is pretty intense. So for this one, I want to enable it only when the car was essentially peeling out. So for that, I made some logic to identify that. Basically, if it's on the first gear and if it's accelerating a bit. If so, then enables that particle effect. And just in case you don't know how to modify a particle system through code, this is exactly how you do it. So you go inside the particle system, you grab the emission, so this is the emission module. Then you can just modify that object and you don't need to assign it back into the object. So this one is a nice reference, so just modify, do whatever you want with it, and changes all happen exactly. Another small effect is the exhaust backfire. So look at the exhaust down there as I change gears. So as I change, boom, there you go, there it is, and there it is. Yep, that's a nice, subtle, nice effect. The way that works is obviously based on changing gears, and here the car actually fires off an event when the gear is changed, and when it happens, really just set that effect to true. Pretty simple, looks quite nice. Again, the main takeaway from all this is really just separating the logic and the visuals. That way over here the car visual script, this one is pretty compact, and the logic script, this one is also pretty compact. Each of them handles a different thing, and all the logic is nice and contained. Then for the AI logic, making the easy, normal, and hard. For this one I went with a super basic approach since this is really just a simple minigame. Basically, I just played the game for myself and I saw where would I change gears. So I intentionally played quite badly and then saw when I changed gears. So over here when speed is on 66, 67, then over here like this and so on. So I just did that and stored those values. And then I stored those values in 3 nice scriptable objects. So here I've got the easy and there you go. You can see the max speed where it actually changes gear. So that one changes from the first to the second gear when it's at 26% of the total max speed. Then the normal one is going to change a bit earlier and the hard one is going to change a bit more. And here is the car AI script, which really just matches exactly what I did. So once it gets to that point, it simply swaps the gear. And same thing for NOS, when it gets to that point, it simply enables NOS. Now the more interesting part is how the AI actually uses these inputs. The answer is related to what I mentioned a while ago, which are these delegates over here on the car script. Basically, both the player and the AI, both of them use the exact same car script. And in order to control it, there are these delegates, so the throttle input, the brake, gear change, and the NOS. Now if you don't know about delegates, I cover them in detail in another video. Basically I have these delegates on the main car script, and then I have the car AI and the car player script, which actually sets those inputs. As you can see for the car player, for this one does use the input, so the inputs from the player, so the usual stuff. And for the car AI script, it receives that SO with all those values and simply uses those to drive the actual car. This way the base car script is shared between both of them, which really simplifies things. The AI logic really only exists in this one script. This is exactly the same thing that I did in my upcoming Steam game, Dinky Guardians. In order to record the announcement trailer, right now the game doesn't yet have multiplayer implemented, so for controlling multiple characters for the trailer, for that I made some simple AI bots that do exactly this. So I can control the characters myself, or I can have the AI control them, all of them using this exact same method by doing that through delegates, which can be based on player input or some AI. By the way, go ahead and add Dinky Guardians to your wishlist. And now for the really fun part, the speed effects. These are a bunch of small effects that when you put them together, they really help sell the sense of speed. Here are 2 shots side by side. You can easily see the massive difference all of these effects makes. This is the same thing that I always say, which is how polish is what separates good games from great games. Adding just that little bit of polish to really sell the sense of speed really takes this game to the next level. So let's see all the effects that I added. The logic is all being handled by this script, again separating the visuals from the logic. Now the most obvious one for getting that sense of speed is changing the field of view. So here if I were to position the camera right behind the car. Also by the way, one quick tip, you can actually modify the field of view for the scene camera itself. Just go into the top right corner and yep, over here you can modify the field of view. So with 40 it looks like this, so if the car was moving it would look decently fast. But as I increase it, just like this, the edges are much more distorted, which really helps sell the sense of speed. So that's exactly what I'm doing over here in this script. Now I covered how to modify scene machine parameters through code in another video. Here you can see that I'm grabbing the reference to the virtual camera. And then over here on late update, I'm grabbing the lens settings. And just doing a simple mathf.lerp in order to interpolate between the minimum field of view and the maximum field of view. And going to do that based on the car speed normalized. So this is really just the current speed divided by the maximum speed. So as the car speeds up, the field of view goes closer to the maximum. So it goes between 40 FOV and 100 FOV, which is pretty intense. Then the next effect is the camera position. If I just have the camera looking straight from the side and over here I increase the FOV, that really doesn't change much. So the second effect is as the FOV increases, as the car speed increases, the camera also slowly goes behind the car. That's this simple line right here. So it just grabs the cinemachine transposer from the virtual camera, which by the way, this is how the main camera is set up. So as you can see, it just has a transposer, so all of it pretty basic. By default, it's looking from the side, so with the default offset with X and Y and 0 on the Z. And then once again, it interpolates the values between minimum and maximum based on the car speed normalized, and those values are up here. So it starts off looking from the side and ends up looking pretty much from behind. And the final effect is the screen shake. So for that, over here on the virtual camera, I had over here a noise, a basic multi-channel purlin. So it has a certain amplitude and frequency. And again, over here through the script, trying to do the exact same thing. So it basically gets that multi-channel purlin. It gets it through here, the gets in machine component. Gets that one, and when again the exact same thing, just using mathf.lerp with the car speed normalized in order to go from 0 to the maximum. Basically, as the car goes faster, it's going to shake the camera more and more. With all those tiny things, as the car speeds up, the camera goes behind. It increases the FOV and starts shaking, which really helps sell the sense of speed. Again, looking at the side by side, you can really tell the difference. So like I always say, polish is what separates good games from great, so definitely make sure you spend some time polishing your games to really make them shine. Put all that together and this minigame came out quite well, nice, small and fun. Go ahead and download the free project files and try to beat my time. Again, the reason why I made this game is because this Street Racer pack is currently on the flash deal on the Cinti sale. If you have any idea for which you need a bunch of cars and racing things, then definitely check it out. The pack has tons of stuff, so you could make a game like this, or maybe make some kind of car mechanic game, maybe something like Crazy Taxi, or really just a basic racer. The project files for this video includes one scene without assets, and one scene which will automatically load the racer pack if you import those into the same project. Beyond that, check out everything else on the Cinti store. If you like their style just like I do, then definitely give it a look. There's tons of awesome stuff on all kinds of themes that you can use to make an endless amount of unique games. Alright, I hope you found this video interesting, thank you for watching, and I'll see you next time.